you to definite integrals. Okay, so far everything that we solved, we just had an open integral. Okay, for the integration. What if I ask you to integrate from, let's say, 0, okay, to say 3, okay, of the function maybe x cubed with respect to dx? Yeah. So here the key difference is you integrate all right, just like we know, which will be 3x raised to the power 4/4. Okay. But in this case, because you'll be putting in the limits, the lower limit and the upper limit into the function to bring the constant of integration. Okay. So how do we also put the limit in? The bigger value or the upper value will be substituted where you see x. Okay. So that will be 3 raised to the power 4. Okay. Divided by what? 4. Then minus. Then you substitute the smaller value also where you see x. 0 raised to the power 4. Okay. All divided by what? 4. Okay, so this will give us 3 raised to the power 4, which is 81/4, which will be our final answer. Okay, so that will be 20.25. Okay, as the final answer. Okay. Now let's try one more example. So assuming I ask you to integrate integral of 4. So integral of 4 sine, okay, x from 0 to pi, okay, with respect to dx. So this is going to give us 4. When we integrate sine, we'll get what? Cos, negative cos. So we get minus cos of what? X. Okay, good. But take note, we are going to what? Substitute the limit of integration. So from 0 to pi. Okay, good. So this will look like this: 4 times negative. In fact, the negative 1 can even come out. So negative. Then we have cos of pi. Cos of pi plus, sorry, minus cos 0. Okay, good. So let's see what we're going to get when we find cos pi. Here is 180 degrees. Okay, so pi is 180 degrees. So cos of pi, we always know that the cos function is between 1 and -1. Okay, good. And at cos 0, we are at maximum. At 90, we are 0. Okay, and it keeps going forth and on. Okay, good. So at cos 0, we are at +1. At 90, which is pi over 2, we are at 0. And then at cos 180, which is pi, we are at -1. Okay, so that your calculator should be able to give you. So cos 180 is -1 minus cos 0 is +1. Okay, times -4. So -1 minus 1 will be -2. Okay, so which means that we'll get an answer of -4 times minus what? -2. which is equals to positive 8 as our final answer. Okay. If there are any questions, you can ask. If there's any question, you can ask. Okay, so let me take Jonathan.
Hello, sir.
Yeah.
So please read the first one.
Yes.
S with the power 3.
Yes.
Yeah, we've had when we were integrating, we get S raised to the power 4/4.
Yes.
So I don't understand that one, please.
Oh, but the rule of integration says add 1 to the exponent. So when you add 1 to the exponent, what will you get?
Okay, so you get 4. I wasn't there at the beginning.
So you add 1 to the exponent and then divide by what you get.
Thank you, sir.
Yeah. Desmond.
So please, good morning.
Yeah, please, when you come in, don't greet. Just go ahead.
All right. So please, my question is, so when we were integrating the x power 3, we divided it by 4.
Yes.
But when we were integrating the sign, I thought we also divide by -4.
It means that you didn't write the rules for differentiating sign, for integrating sign.
It was my network, so I just moved from home, then I was getting the good network.
You'll get the slide. When you integrate sign, you get negative cos.
Oh, okay. Okay, sir.
Mensa.
Please, I don't understand the point where you illustrated the pi on the graph on the number line, please. Can you go over that way, please, again?
Okay, I'll do that. Who else? Kwanzaa. Kwanzaa Samuel. I've muted you. I've unmuted you. So go ahead.
Sir.
Now, if you remember, okay, angles in degrees, pi over 2, okay, in degrees is the same as 90 degrees. And then pi is 180 degrees. Okay, good. Then again, from lecture 1, you will know that sine of, okay, 90 degrees, or let's start with the cos first. So cos 90 degrees, okay, we all know cos 90 is always what? 0, okay, while sine 90 degrees is equal to 1. Now, when we plotted the graphs for sine and cos, let me see if I can get a demonstrator. So at 1 and at -1, okay. Okay, so in our first class, when we plotted the functions for cos and sine, you may probably go back and then just go and plot those functions again using Scilab, okay? So when we are plotting for cost function, you find out that we have a sine wave like this, okay? Oh, sorry. A sine wave which goes like that. Okay, and it keeps going on and going on. Good. So this is the cost function. So this is cost of the function x, okay, where x, well, as it stands now, we can say that x is between negative pi to 5/2 pi, okay, good. So once you plot this function, you will always find out that cos 90, this is cos 90. This is a point cos 90, okay, cos at pi/2, okay, cos at pi/2, okay, it's always 0. Whilst cos at 0 is what? 1. Cos at 180 is going to be -1, okay, and it keeps going on and on and on. Cos at 270 will be 0. Cos at 360 will be +1, okay, but the sine function, okay, will differ, right? So sine will be 0, okay, at angle of 0, and will be 1, okay, at pi/2, okay. So the sine function, okay, always leads our cos function by pi/2. So it keeps going like that, right? Good. So that is how the sine function also behaves. So this is the curve for sine. Sine of x. So at 90 degrees, okay, sine is going to be 1. At 0 degrees, sine is 0, whilst cos is 1, and keeps going forth on and on and on, okay? So let's go back to the definite integral we're looking at. So given this, okay, we have 4 into bracket negative cos x evaluated from 0 to pi. So let's go back to our whiteboard and do that. So we have 4 into bracket, I think negative, okay, cos x, okay, being integrated from 0 to pi. Good. So it's very simple. What you do here is this will be 4, okay, then substitute the upper limit first. So 4 minus cos of what? So in place of x, you put pi, okay, good. And then it will be minus of negative cos. So you always subtract the evaluation of the lower limit from the upper limit, okay? So minus the negative of cos 0, okay, good. Now we've just seen what cos 90 is, which is cos pi, sorry, cos 180 is, which is cos pi. And then we've seen what cos 0(2) is, okay, good. So the question is, what is cos 180? So cos 0 was +1, cos 90 is 0, cos 180 is -1. You can also find the computation from your calculators, okay? You can use your calculators, but make sure it's in the degree mode. So we have, this is -1 minus will give us plus. Then cos 0 will be what? Cos 0 is what? 1. Okay, cos 0 is 1. So this will give us 4 into bracket, negative is positive, plus 1 which will give us what? 8 times 2 will be equal, 4 times 2 will be equal to what? 8. Okay, so that gives us the result as we saw earlier. Good. Okay, we are going to look at integration by parts. What do we mean by integration by parts? Integration by parts, okay, is simply obtained using the product rule. Okay, we derive it from the product rule. Okay, and the rule, this is the rule. So we can show from the product rule that if you want the integral of a function u dv, then it's going to be u times v minus what? The integral of v du. Okay, so the question is, what kind of function can be even expressed as u dv? Okay, and we have examples here. Look at these examples. So you have one function u, which is x, and another function sine x. Okay, two functions multiply. So one is u, the other is what? V. Okay, good. The same way, x squared cos x. You see two different functions multiplying each other with a dx. So anytime you see it in that form, then we have the scenario u dv scenario. Okay, good. Now the question is, how do we apply the formula? So take note of the formula. U dv is equals to uv minus integral of v du. Take note of the formula. If you please write it down so that you don't come back saying you didn't get it. Write it down. So if we are given any function like we saw earlier, like for example, integral of x sine, okay, x sine of x dx, okay, then what you do is we'll let okay, so given this function, we said we will let one of them be equal to u and the other be equal to dv, because it needs to be expressed like this. So one term will be equal to u and the other term be equal to dv. So that's the first thing you're going to do. Then after that, you are going to what? Find, after you've made one be equal to u. So for example, you let, okay, u be equal to x, and then dv be equal to what? Be equal to sine x with the dx. Okay, good. So after that, the next step is you will find the u dx. Okay, so meaning you differentiate the u with respect to s. So the u dx, okay, will be equal to what? 1. I hope you understand. Good. And then you will find v, and you have dv here. So you find v, meaning you integrate. Okay, so you integrate with respect to what? X. So you find v. So when you find v will give us what? When we integrate sine x, what do you get? You get negative cos x. Okay, this time you will not bring the constant of integration. Okay, good. So these are the steps. Then you come and substitute it. You come and substitute this into the formula, having known your u, your v, because you have your u from here. So you have your u here, which will be this one. You have your v here, which will be this one. Okay, minus integral of the v is here. Then the du is what you found over here. Okay. Good. Now, so that basically is the step. Let's try some few examples, okay, on how to solve this. So let's put down the step. We are saying that, so for example, if you have the function, if you ask to integrate what, okay, x dx, x sine x dx, okay, first, just like we discussed, make u be equal to x, and let dv be also be equal to sine x, which means that du dx is equals to 1, okay, good. And then dv, sorry, v by integration, this means that dv, okay, is equals to what, sine x dx, okay, good. So when I integrate both sides, it means I'll integrate sine x to get my v, and that gives us negative cos, okay, good. So then we bring in the values. So applying this formula, then the integral of x sine x dx will be equal to what? Will be equal to your u. Your u is what? X, okay? So this is your ux. So look at it carefully. Your u is this x here. This is your u, okay, x. Then this is your v minus cos. So it will be negative x cos x minus, per the rule, there is a minus here. You can see it. There's a minus here. So minus the integral of what? V, which is what? Negative cos. So this v negative cos. And then the u, look at it carefully here. The u dx is 1. So it means that we can write the u is equal to what? 1 dx, okay? Meaning we multiply both sides by the denominator, okay? So 1 dx. So it means that the u is what? The x, okay? So study it carefully and let's continue. Good. So once we've done that, this will become, this now becomes what? Negative x cos x minus, when we integrate, don't forget, when we integrate cos x, it is negative cos x. So the minus can come out. So we have negative negative. When you integrate cos x, you get what? Sine x. Okay, good. Then bring your constant of integration. Good. So that will simplify to give us what? Negative cos x, okay, negative x cos x plus sine x plus c, which if we rearrange will give us sine x minus x cos x plus c for the final answer. In our second example, we are finding the integral of x e raised to the power 2x dx, okay? And once again, it's a product of two functions. So it means we use integration by parts, right? And carefully select your u. So here u is x. Then dividing the x will also be what? Dividing the x is also going to be what? Just a minute, please. So per what we said, if you want the integral of u dv, okay, good, is going to be what? Per the formula. So the integral of u dv, right? So we let u be equal to x, and then dv, okay, be equal to what? You pick the remaining terms here. So that is e raised to the power what? 2x, okay, dx. Is much simpler seeing it this way. So dv is e raised to the power 2x dx, okay? But here, both, I mean, both sides of the equation have been divided through by dx. That is why we are seeing this. Okay, good. Now, what's next? If u is x, then du dx is 1. Okay, good. Which also means that du is equals to what? Is equals to dx. Okay, then if dv is e raised to the power 2x, then it means that what? When we integrate this and integrate this, integrating dv will give you v, and integrating e raised to the power 2x will give you e raised to the power 2x over what? 2. Okay, and once again at this stage, don't bring the integral, don't bring the constant of integration. Okay, good. So which means that our v is what? E raised to the power 2x over 2. And let me write this. The u is dx. Okay, good. So then per the formula, we are coming to put in the various values. Let me write this too, okay, for the sake of convenience. Good. So we are going to substitute. So integral of, so the integral of x e raised to the power 2x now becomes now becomes what? Your u is x, your v is e raised to the power 2x, okay, over 2 minus integral of e raised to the power 2x over 2 dx. Okay, good. And then when we integrate this other side, when we integrate this e raised to the power 2x over 2, okay, it looks like it's going to be like this: 1 over 2 e raised to the power 2x dx. Okay, meaning I bring the 1 over 2 out and integrate. And when I integrate e raised to the power 2x, you still get e raised to the power 2x over 2. Okay, and already there is a half outside the integration. Okay, so that will be half times e raised to the power 2 over 2. That is why we are getting e raised to the power 2x over 4. Okay, for the integral of this. Then of course you bring your constant of integration in the very final step. If there are any questions, you can bring them up. Any questions before we move on? So we take the next one, integral of 8x ln s dx. Okay, good. So what do we do? Now be very careful. In this case, ln x dx will keep repeating itself if you make it the dv. So you rather make ln x, make ln x equals to u, and then make the remaining term, which will be 8x dx, equal to v. So make your dv rather what? 8x dx. Okay, so that is what you have to do in this case. So where you have a lane and a polynomial function, make sure you make your lane function, okay, equal to u. Good. Now from there, we can integrate this, means we have integral of 8x will be what? 8x squared over 2. So that will give us 4x raised to the power 2 for v. That is what we are seeing here. Then for the derivative of ln x, we know is 1 over u. So you differentiate the function here, okay, over the function from derivative class. So 1 over x, which will mean that du okay, or let me say du will be equal to what? 1 over x, 1 over x with respect to the x. That's if I multiply both sides by the x, okay? So du is 1 over x dx. So once again, we are done with what we have to do, and then we have to now substitute our u, our the v, and then the v into the formula. So the integral, which means the integral of 8x ln x dx now becomes what? What is your u? Your u is what? Your u in this case is what? Ln x. So we bring it times what is our v? Our v is what? 4x squared. So we bring it minus the integral of v. So this is v. V is what? 4x squared. We bring it. Then times du. What is du? Du is what? 1 over x dx. So you bring it here. Okay, so that does it for our substitution. So look at it carefully. Okay, now let's continue. Yeah. So after we've substituted, what next? This, if you look at this carefully, this x will cancel out one of the x here and we'll be left with x, okay? So then we are left with 4x dx here. And when we integrate 4x dx, if you like, bring the 4 out, then here you get x squared over 2, okay? So 4x squared over 2. So the 2 will cancel out the 4 and you get 2 here. So it will be remaining what? 2x squared. So you get 2x squared from the integral. And your final answer will be what? 4x squared ln x minus 2x squared plus c. Okay. So when we're doing product rule, the u dv is equals to dx gave you what? You had u dv, okay, plus what? Or u dv dx, let me put it that way. Okay, plus what? V du dx. This is differentiation. Now, if I multiply through by dx, all the denominators will go away, okay? If I multiply all the terms by dx, we multiply here by dx, all the denominators will go away. So you'll be left with du v is equals to u dv plus v du, okay? Then integrating all sides or both sides will give us integral of du v is equal to integral of u dv plus integral of what? V du, okay? But the integral and the derivative, okay, are inverse functions or opposite functions, so they will cancel out. So you are left with uv is equals to integral of what? U dv plus what? Plus integral of v du. Good. So you see from this formula, if I want to make this the subject, it just becomes what? U dv is equal to your left-hand side, which is what? uv. When this goes there, it will become negative, and when it crosses the equal sign. So minus integral of v du. So this is the formula which we are using here for the integration by parts, okay? It was simply derived from the product rule. Okay. I can see a hand up. Yes, Noah. Yes, Noah. Yeah.
Yeah, please. I understand up to this point, these very points, but